So first, let's get started with the Google Colab notebook. On your Chrome browser, type out this link and press enter. So if you've already signed up to Google Colab notebook, this interface is what's going to open up. If you haven't, just sign in with your personal Gmail ID and password. So when this opens up, you'll see this notebook known as Welcome to Collaboratory. So this is a notebook that's pre-given by Google, and it has certain commands and instructions on how to operate with Colab notebook. So I'd encourage everyone to have a look at it. Now let's start by creating our new notebook by pressing this button. So something about Google Colab is that this is a product that was developed by the Google research team. And the reason as to why it's very well preferred is because there is no setup or installation required for its usage. As you all just saw, all you have to do is enter in with your Gmail account. So what I have in front of my screen is a code cell. So this is a cell where you write and execute your code. Suppose I write the code there. You can execute the code in one of three ways. Either press Shift and Enter, or Control and Enter, or you can just press this button over here. So you can add additional code cells by pressing this button here, or you can also press this button here. And there's also a provision for adding text cells. So these cells help you add comments and give explanations on what your code is. So you can do that by pressing this button or this button as well. Once your code cell has executed, there'll be a number that's appeared on the left side of the cell. You can do other functionalities such as navigate through cells by pressing these arrows. You can copy cells and cut cells or delete the cells that are redundant. Now, to understand a little more about the interface, Google Colab provides a table of contents. So with this table of contents, what we can do is add sections in our code. So while you add sections in your code, this allows you to visit a particular set of code to analyze it, basically look over it, so it's easier and more organized. Then we have the find and replace part. So here you can look for a phrase or a word in this code and then replace it with another. Then we have certain pre-given code snippets that can be incorporated into our code. And then we have a file section. So for the session or the section that you're coding, if you require maybe some sample data sets or images, you can upload them using this. So one thing to note is that the uploaded files will only remain as long as your Google Collaboratory notebook is connected to the cloud. So after around 30 minutes of inactivity, it gets disconnected. In that case, you'll have to upload it again. So a reason as to why people, again, prefer Google Colab is because it works in a manner that's similar to Google Docs. You can share this notebook with people and multiple people can work on it simultaneously. Another thing is that it allows you to use Google's hardware freely, such as GPUs and TPUs. And to use this, all you have to do is go to Runtime, click on Change Runtime Type. By default, you'll get a None option here. And then you can either select a GPU or a TPU. So a GPU stands for Graphical Processing Unit and a TPU is Tensor Processing Unit. More about these features will be explained in the forthcoming sessions. So you can do additional things such as open a new notebook, open a pre-saved notebook, or you can also download it locally in the .ipynb format, which is the IPython notebook, or the .py format. So that was all about the basic interface that is Google Colab. Now let's jump right into the main session. What is Python? So Python is a general purpose programming language. It's very simple to write, has a very user-friendly syntax. And if you look at a Python code, it quite resembles the pseudocodes that you write. One important thing to note in Python and how it's different from languages such as Java and C++ is that in Python, you have lines of code. In Java and C++, you have lines of code that are covered in curly braces, and these are known as blocks. While in Python, you don't have such blocks. You rather have indentation. So when you're coding different subsections, what you do is you indent it from the main section. Now, Python is an interpreted language. What this means is that it requires an interpreter for its execution. When you run a Python code, what happens in the back end is that the entire code first gets compiled and gets converted into something known as a bytecode. Now, this bytecode is very easily executable using an interpreter, which basically runs each of those codes line by line. This was developed by Guido van Rossum in the year 1989. Now, why is it used? Why is Python so popular? That's because it has a vast collection of libraries for scientific computing and plotting, such as NumPy, SciPy, Matplotlib, Pandas, and all this is what makes it very unique as it increases the functionality of Python. It also has a wide range of applications in the field of machine learning, data science, and web development. So Python versions. Python has two versions mainly, which is version 2 and version 3. And as of April 2020, the Google Collaboratory Notebook runs on Python version 3.6.9. So to check your Python version, you can run this command. So that tells you the Python version, which is 3.6.9. Now let's talk about variables and data types in Python. A variable is basically a container that stores one single value. Think of it to be like, let's say, a basket or a bag that just stores one particular item. So this basket or a bag is what a variable is. It's a container. Now, in a basket or a bag, the kind of item that you store can be classified into different categories, right? For example, in a basket, you could store apple or oranges or other types of fruits. That's the category. Or in a bag, you may store books. So these are categories of the items that you can store. So in the similar manner, the value that's stored in a variable has a category or a label, and this is known as a data type. So the data types in Python are integer, floating point numeral, complex class, string, and Boolean. So let's look at each of these data types. So in this code cell, there's a variable a, and to that we've assigned the number 5. And then we're printing the number that is 5, which is stored in the variable a, and its type. So this function basically prints out the data type of the variable. So as you can see, 5 is printed and it's of the class belonging to int. So by default, when you store a value like this in a variable in Python, it's of the type integer. Now let's store this number 2.5 in the variable b. So as you can see, 2.5 gets printed and the type is float. Now let's store 2 plus 5j in a variable c. So this is of the class complex. As we can see, it is a complex number because it has a real part and an imaginary part. Now let's store the words double quotes within double quotes in the variable s1 and the words single quotes within single quotes in the variable s2 and look at each of their types. So we can see that both double quotes and single quotes are of the type string. So anything in Python that's enclosed within either a double quote or a single quote is called a string. Now let's store this word true in. So we can see that the word true belongs to the type Boolean. And Boolean has two types of values, which is either true or false. So that was the basic overview of the different data types in Python. Now with these data types, there might be numerous operations that can be performed. And these operations can broadly be classified into three kinds, which is arithmetic operations, logical operations, and relational operations. So let's start with arithmetic operations. Arithmetic operations are the basic addition, subtraction, multiplication. And for exponentiation in Python, we use a double asterisk. So we can see that we first stored 5 in the variable x, and then when we added it, it became 6. The difference is 4. The product is 10, and the exponentiation is 25. So these commands would work quite similarly in case of a floating point numeral as well. Let's take, for example, 5.8. As we can see, we see the sum, difference, product, and exponentiation all over again. Now let's apply the same arithmetic operations to a string data type and see what happens. So we can see that when the string Python was multiplied with 2, it was repeated twice. So when the asterisk or the multiplication operator is used with a string, it basically repeats that string those many number of times, which is 2 in this case. Here, we're adding the string s with another string 2. So that forms Python 2, and this is known as concatenation. Now let's see what happens if we remove these double quotes. So as we can see, there's an error here, and it says must be str not int. What we're doing here actually is adding a string with an integer, which is not possible because we're trying to add two different data types. So we must add string with string, and that forms the operation of concatenation. Now let's move on to logical operations. Here we're taking two Boolean variables, t and f, and storing true in t and false in f. Now let's run the logical and, or, and not for these variables. So we can see that t and f give you false, t or f gives you true, and not t gives you false. To explain this, let me take a simple example. Imagine you're going to write an exam and your invigilator says, to be present in the exam hall, you need both a pen and a pencil. So the and word is used here. So let's assume you had a pen, so that is true, but you didn't have a pencil, so that's false. So that means your total output is false. You won't be allowed to sit in the exam. Now let's assume that the invigilator said that you need either a pen or a pencil to attend the examination. That means you did have a pen, but you didn't have a pencil. But that's perfectly fine because it was or that was used. And now let's assume that the invigilator said you cannot bring a pen. So all you had was a pen and you cannot bring that pen. So that is false. So that was all about logical operations. Let's talk about relational operations. Relational operations are basically used to compare two given values. So here we have the variable a that has the value 5 and another variable b that has the value 6. So when we print statements out like this, such as b greater than a or equal to, the final output will be of the type Boolean. So when you say b greater than a, that is 6 greater than 5, that's a true statement. So that prints out to be true. When we say b equal to a, that is 6 equal to 5, that's a false statement. B lesser than equal to a, 6 is not lesser than equal to 5. So that's a false statement. B not equal to a, yes, 6 is not equal to 5. So that's a true statement. One very important thing to note here is that this equal to is very different from this equal to. Here equal to is a relational operator. It is used to compare the operands that are present on either side, that is B and A. While this single equal to is an assignment operator. It assigns this value to this variable. So mostly these kind of statements that use a relational operator are used in conditional statements such as if and else. So before we look at the conditional statements, let's have a look at the print and input statement. So this is the print statement and that's used to display output to the console. So as we can see, there were many print statements used and that displays the output here accordingly. Now an input statement is used to take in input from the user. So here we're having a variable x and then we're taking in an input and we say enter a number. So within this input parameter, we're giving in our statement that needs to be displayed. By default, the input takes in a value of the data type string. So if you want it to be of another data type, we must typecast it. So that's what we're doing here by enclosing it within these int brackets. And then we're printing the division by 2. So let's see what happens. I enter number 6. And it prints the division, that is 6 divided by 2, 3. So print and input statements are very common in code. Now let's go back to conditional statements. Conditional statements are of two types. You have if else or if, elif, and else. So let's look at the difference between these. Let's take two variables, x and y. X has the value 9 and y has the value 10. Now let's run if else. So what if else here does is if x is greater than y, then you print this statement of code. Else you print this statement of code. So let's see what happens. When we run this with x as 9 and y as 10, we get the output that 9 is lesser than 10. That is x is lesser than y, and that's true. Since this condition was false, it printed this condition. Now let's understand what if elif else is. So with if and else, you can have only one condition. So if that condition is true, you print this, else you print this. While with if elif else, you can have more than one condition. So here we have if x is greater than y, print this. Elif means else if. So else if x equal to y, then print this. Otherwise, print this. So let's run this code. So here we can see that the output is 9 is less than 10, which is the same as this. Now, if I were to change the value of x to 10, with this section of code, what happens is it prints that 10 is lesser than 10, which is not a right statement. However, with this section of code, it says that 10 is equal to 10. That's because we gave multiple conditions here. So depending upon its usage in code, we can use either an if-else statement or an if-elif-else statement. Sometimes just an if-else statement is enough, and sometimes, as in this scenario that was given, an if-elif-else statement is required. There are certain cases in your code where you'll see that just a standalone if is more than enough. So that was about the conditional statements. Now let's talk about loops. So what is a loop? A loop is basically a set of code or just one line of code that is repeated multiple times. So if I ask you to print the text Python 5 times, you can very easily do it by typing Python and then copy pasting that code 5 times. But what if I ask you to print that 100 times or 1,000 times? That would require a lot of manual effort, right? And the manual effort that you'll be putting in would be pretty redundant. So instead, we can use a loop. So there are two basic loops in Python. One is the for loop and the other is the while loop. So this is a syntax for a for loop. We're saying for, and then we're giving I. I is the loop control variable. And then we say in the range of 5. This means that I, the variable I, will range from value 0 to value 4. And in this range, print the word Python. So this is what happens here. Python gets printed 5 times. Now let's try running the same code in a while loop. So in while loop, we first initialize the loop control variable to 0. And then we give a condition using relational operations. And we say that run these 2 lines of code as long as I is less than 5. So what are the 2 lines of code? We print the word Python, and then we increment the value of I. So we see that the same output is displayed in both scenarios. Next, over to Aditya, who will be explaining containers in Python.
Thank you, Sneha. So next up, we are looking at containers in Python. So when we come to containers, main reason we use containers is that we won't want to use the basic data types always. We always want a collection of data as the next level of storing data in Python or any programming language for that reason. So most widely used data type is list. So a list, very similar to an array, it's an ordered collection of data. So a list is mutable. You can edit the elements of a list. It allows duplicate values. So the syntax goes like same as before. The identifier L1 equal to your data enclosed in square brackets separated by commas. So here we see Python, C, Java, 3 very popular programming languages. So this this specific list L1 stores Python, C, Java, but a list in Python is not specific to data types. It can store multiple data types, and unlike the first one where it has only strings. So when we run this, we can see how our lists L1 and L3 look like. Yeah, so our list L1 looks something like this: Python, C, Java, and then the list L2, a combination of strings and integers, because the list isn't specific to a given data type. So next up, we look at list comprehensions. Now, list comprehensions is an interesting way to optimize code. So firstly, we look at nums. Nums is a collection 0 to 4. Now we want to square all these elements and store that into another identifier squares. So in a given programming language, say C, we would initialize a new array, then we would write a for loop and then append each element onto our list or the array there. But here we can see that squares equal to enclosed by square brackets. We can do x square for x in nums. So for x in nums, as you know, we'll make x iterate through nums, that is 0, 1, 2, 3, 4. So x will be squared, and then those elements will be stored onto squares, the identifier squares. So squares will hold a list that has the list of the previous numbers squared here. We can run that and check it out. So as you can see, we have the squared of all those numbers. So we can even prevent it to a specific condition that my x has to be even, and I don't want all the odd numbers. So that way we just add if x mod 2 equal to 0. You know how mod 2 works. So x mod 2. What is the remainder when we divide x by 2? In case it's 0, we know that our number is even. So all those numbers squared will be present in even squares. So let's look at even squares now. 0, 4, 16. Perfect. Cool. Now let's look at tuples. So Python doesn't restrict itself to only a single collection object. We have like 4 of them. Second one coming on to tuples. So tuples very similar, except that here tuples are immutable. Once you initialize them to a specific data, like here 5 comma 6, you can't alter them. You can't edit single elements inside the tuple. So t equal to here we use curve brackets, the round ones, normal ones, unlike we use the square ones in lists. So we can check out how it looks. We don't have much to look at here because it's just singular and immutable. So next up we can look at dictionaries. So previously we can look at lists and tuples where the index of data was specified by the interpreter, which was 0 and 1. Here, when we look at this list, the index of all these elements are 0, 1, and so on. Rather than that, you can look at this Python. L1 of 0 would have given us Python. So let's look at that once. L1 0. So that would give us Python, and so on C and Java with 1 and 2. We have to note that it starts at 0 and not like 1, 2, 3. Because it's a programming language, we don't want to waste any bits or memory here. So in a dictionary, rather than index being specified previously, we specify our own index. So a dictionary is mutable. It is a collection of key value pairs. So it allows duplicate values but not duplicate keys, because a specific key should identify or point you towards a specific data point. So here we use the flower brackets, or we can use the function dict. So here we store a dictionary that has the animal and a property of the animal. So a cat, the index cat points to the data point cute. A cat is cute. So second one dog, a dog is furry. So this is how we access the elements in a dictionary. D of cat, which will point us to cute. Let's check that out. So cute. This shows how what happened when we access D of cat. So now in this statement, cat in D, this specific statement checks whether the cat index is present in our dictionary. So we know that cat is present. To check whether in is an operator that basically iterates through the whole dictionary and checks whether the specific data point is present in the dictionary. This works with all other data containers also. We are showing you with this example. So that'll print us out true because cat is present there. So next up we see how we can add more data elements onto our dictionary. So we add the animal fish. So property of the fish is that it's wet. So fish equal to wet, D of fish. So this is the syntax we follow to append more data onto our dictionary. So print D of fish, we will be expecting wet. So it should be something like this, right? So again, the comprehensions. As we saw previous list comprehensions, we mentioned um, specific data elements that we want in our list. Here we mention the specific Index and data element we want in our dictionary. So as we saw in our previous problem, we had nums, and then we do something where that specific number points to its own square. So if you look at how this dictionary looks, it is something like this. So if you want to do something like, I want to know what the square of say 4 is. Even number to square, the identifier of 4 is 16. So perfect. There we go. Next up, we'll look at sets. So sets are an unordered collection of data. You might have heard about sets in maths. It's the same thing, but implemented in code, in a programming language. So Python tries to cover a lot of areas using the default available collections. So sets, it's an unordered collection of data. Um, Values can be altered. A set is mutable. You can edit the elements in a set. We won't allow duplicate values, respecting the how the definition of set is. Here also we use flar brackets, but brackets. But rather than giving key value pairs like this, we give only data, like we gave in the lists and tuples. So we just give the cat and dog, and again we can check cat in animals, fish in animals. So fish prints false because it isn't present. Cat is present, so we'll get true. So yeah, true, false. So to add more elements or remove elements, we can use the function add and remove, which does the same. 2 and 1. So we add a cat, we remove it. So when we add it, it's so. Rather than just doing that, let's look how the whole set looks. So put animals. Yeah. So when we added a cat, the we can see that the cat is present right now. Actually, it was previously present, but because sets don't have duplicate values, we don't see any increase. But when we remove it, it isn't present. So if you want to know more about sets or anything about Python, you can head over to the documentation. Or there's a more easy way where you can do something like um, set, or we have our animals stored, animals dot remove. That was the operation we just worked with, and then a question mark, running which we'll get a proper explanation of what our method is. So it specifies remove an element from a set. It must be a member. In case the cat wasn't present in our set, it would have thrown us an error. So that's how that works. So again, we have the comprehensions, same as before. Here we perform the operation int x by 2 for x in range 10. Range is a function that gives us a collection from all the way from 0 till 10, as we specify 10. The starting point also can be specified as we see appropriate. So 0 till 9, because Python is write exclusive. 10 won't be included. So when we run this, we see a set from 0, 1, 2, 3, 4. So 9 by 2, which is 4.5, we convert it to an integer. So 4.5 will be 4. So we'll get 4 twice. All the elements will be twice, which because sets reduct or remove duplicate values, we see only 5 elements here. 0, 1, 2, 3, 4. You can verify the same. So oh yeah, now coming on to slicing. Slicing is a very useful topic. So to demonstrate slicing, best ways to look at examples. So syntactically, we use nums, a square bracket, two colons. The first value specified would be the starting point. Second value would be the end point. Because Python is right exclusive, the ending point will not be considered. Only one value before the ending point will be considered. And then the last one is the step. By how much should I increase or how much should I decrease? Because it's -1, this specific example will decrease. Firstly, let's create a list to play with and look how it works. So we create nums. This is how nums look like. My new list nums. It has all the elements 0 to 9. Note here that index of these numbers are analogous to the data points. So 0 index will point to 0, 1, and so on. So now nums 2 till 6. 6 wouldn't be printed because it's right exclusive. We start at 2 all the way till 5. 2, 3, 4, 5. Perfect. So another way is to not mention a specific point. When we don't mention, it goes all the way till the end. If in case we don't mention the first one, it starts at the beginning, that is 0. In case we don't mention the right one, it goes till the end, that is 9. So even on this, we get 5 till 9, that's the first one. We get 0 till 3, that's the second one. So next up, we look at the step operation. Because we put a colon and didn't mention anything, the step will be performed on all the elements together. So because we put 4, every fourth element will be printed out. So we start at 0, then +4 +4, 0, 4, 8. Perfect. So in case you want to check whether that's how exact it is, you can put a 3, 0, 3, 6, 9. Now we can also put negative numbers, which will take it on the other way around. Starts at 9, goes till 0. Because it's -1, it works the other way around rather than the start stop previously. So as the starting and stopping, we can even use negative indexes. So -1 points to 0, not 0. Just a second. Yeah, -1 points to the last element, that is 9, -2, 8, and so on till the end. Again, it won't rotate after that. It will only go on until 0 is present. If you try to use something like -10, it will be showing you, no, -11 would be showing you an error because that is out of bounds. So starting from -1, how it looks. Okay, we start at 0, sorry, and we end at -1, which points to 9, right exclusive, so 9 wouldn't be included. So another way, mutation can be done using this slicing. So when we slice a specific list, we can also mutate those elements, and we can actually give them new values. So this is how it looks previously. Now when we mutate it, we expect the elements 2, 3 to change to 8, 9. So previously this 2, 3 elements have changed into 8, 9. So that's how slicing works. Next up, we'll look at loops. So I know we have looked at loops already, but there's another way of using loops, that is iterating through the collection we just discussed. So firstly, let us look at lists. So I have a list cat, dog, monkey. So I can iterate over this list for animal and animals. Print the animal. I see the type as mentioned here as a list. I'll see that the animals are printed. For animal and animals, the keyword animal or the identifier animal iterates over the list animals. So the same thing happens when we take a set. Rather, a set is unordered. The order changes. When we go on to a tuple, we are back to the order cat, dog, monkey. Hmm. Dictionary is something that works a bit differently. So in a dictionary, when we do for animal and animals, our animal, the identifier animal iterates over the indexes of the dictionary, that is A, B, and C. So animal would be the index, and for when we want to access the specific data point that index points to, we need to use animals square bracket that animal. So when we do that, you can see A points to cat, B points to dog, C points to monkey. So that's how you can iterate over these. There are many more complex ways you can delve onto it in the documentation or more resources. So functions. Functions is one important aspect of every programming languages. Every programming language which provides you with reusability. You don't need to rewrite the same code everywhere you use it. You can just create a function. So here I create a function that takes x as a parameter, returns what x is, positive, negative, or 0. So again, for x in a list that holds -1, 0, 1, on a print the sign x has. So we would be expecting -1 to print negative, 0 to print 0, and 1 to print positive. Also, you would be already knowing how the if, elif, else works. Now let's look at that output. Negative, 0, and positive. Perfect. Make it more clear. Print the number. So we can even have default arguments or default parameters. Remember that the default parameters should be written towards the end of the parameter list. So loud equal to false. Unless we specify loud equal to true, it will be false. So here we are greeting our name or a person. So firstly we will greet Bob. We don't do it in a loud manner. So if loud is false. So we'll go to the else part. So inside the print statement, we can see the dot format method being used. What dot format does is the parameter given to dot format will be put into the place of the flower brackets present inside the string. So first we'll just see hello Bob, but in the second hello Bob, in the second one we'll see everything capitalized. That is name dot upper. Upper is a string function that will convert any string, all the characters of the string to uppercase. So looking at that, hello Bob, it's not loud. Hello Fred, we made it loud. Okay, that's about functions. So now moving on to some more important, serious, specific to Python to stuff, map and lambda. So a lambda function, basically like a one-line instant function, rather than creating a function called def and then keeping a name and all that. Normally a lambda function will be used without having an identifier. For our example, we store a function lambda, parameter x, colon, return value x square. So x square is what is being returned through this function. This function, I want to store it onto a variable, say L1. So L1 is my identifier or variable that will store a function that squares x, the input parameter. So L2 returns, so L2 is a recursive function. So now you would have known how recursive function works. You would have made a lot of recursive functions in C and so on. You would have got it in your exams. So in Python, it's as simple as one line. So we return 1 if x is less than 1. Else we return the function with x minus 1 into x. This function terminates when it reaches 1, 0, when it goes below 0. So you can know how this is working. X into x minus 1 and so on into 1 when it reaches 0. So this will perform the factorial of a given number. So let's just run that. We won't be using it that right now. We'll be using it through the map function, which is here. So li is another identifier. It stores the same values which I had in the previous list, all the way from 0 to 9. You do know how the list comprehension works. So m1, my map, it takes in the function l1, which you just see the squares, then the collection li, the list that shows 0 to 9. So when we do that, we would be expecting a collection which shows all the squares. So my li is this, and then all of these elements squared is my m1 list of that map. Remember, map is an object and not a collection. It stores all the values. Unless you change it into a list, you can't see it. If you try to print m1, it'll just show the type of it as far as I remember. It's a map object. It doesn't show you a visualization of what the elements are. So next up, we perform the factorial onto the same element 0 to 9. So when we do that, you see 0's factorial 1, 1 factorial 1, and so on. See 5, 120. So you can see that we did a simple operation. In some 4-5 lines, you perform the factorial of 10 numbers. So in a more general way, the lambda function would not be put into an identifier. Rather, it would be directly specified in our function. That's the map function. So here I make a lambda function on spot, lambda L, which is L is a parameter. I return odd if L mod 2, that is to check whether my given variable or parameter is odd or even. So if L mod 2, that being true, that being 1, my specific element would be odd. That being false, my specific element would be even. So Li is the collection on which we are running the specific operation. So our list 0 to 9 shows us even, odd, analogously. Perfect. So that was from my side. In case you have any doubts, feel free to ask. And so we can move on to our taste of data science.
So hope you guys understood whatever we did so far. So far we spoke about the data types in Python, certain commands and the syntax, and containers, loops, and slicing. Now, one of the most prominent fields in which Python is used is data science. So let's have a small data science application where we load in a data set and try to understand and what the data speaks about. So to do that, we'll be using the iris dataset. Before we run into the commands and how to upload files, let's have a look at the iris dataset. Now this is the iris dataset. Iris is a flower and this speaks about the flower. This is the file format CSV, which stands for comma separated values. And this is quite a popular file format that's used in data analysis. So in data science terms, these columns are known as features and these rows are known as attributes. So let's break this data set down column by column. The first column or feature is ID, which basically works like a serial number. The second feature is the length of the sepal of the iris flower in centimeter. The third feature is the width of the sepal of the iris flower in centimeter. The fourth one is the length of the petal in centimeter. And the fifth one is the width of the petal in centimeter. The final feature speaks about the species of the iris flower. In this data set, there are 3 species that are mentioned, which is Iris setosa, Iris versicolor, and Iris virginica. So that's about the iris data set. Let's have a look at how to import this. This has already been imported here, but if you have to press this button and click on the iris data set to import it. Now let's start by running the commands. First thing we do is we import all the necessary libraries. As we're only doing basic commands here, only the pandas library is required. So we run that and we have imported the Pandas library. Now we're importing the Pandas library as PD. So PD here is an alias name for Pandas. Basically, instead of typing the word Pandas everywhere, instead you can just use the word PD. Now, Pandas is a very popular Python library that's used for data science because it helps you with data manipulation and analysis. It's one of the most basic libraries used in data science. Now, let's store a variable called df and let's store the entire data set in this variable known as df. To read the data set, we use a function known as read underscore CSV. And it's CSV here because that is the file format of our data set. So that has been done and our code currently has imported the pandas library and also read the CSV file. Now let's display the first 5 rows of this data set. To do this, we're using the command df. Df was where the data set was stored and we're using the function head. So now we can see the first 5 rows of the data set and we also have all the columns here as we had seen in the Excel. ID, sepal length centimeter, sepal width centimeter, petal length centimeter, petal width centimeter, and species. So these are the first 5 rows. We can also make it 10 rows or 15 rows just by specifying the parameter here. So now we have the first 10 rows of the iris dataset. Now, if you want to look at the total number of rows and columns in the dataset, we use an attribute known as shape. So this shows us that there are 150 rows and 6 columns, which means that there are 150 attributes and 6 features. Now let's look at the length of the data set. The length of the data set usually mentions the number of attributes, which is basically the number of data points that are present in the data set. So as we saw here, the number of attributes or row was 150. And so we got the same answer here. Now this method, that is df describe, this gives you basic statistical information about your data set. So once you run this, you see that it's feature-wise and it gives you basic statistical information, such as the count of the attributes, which is 150 in all cases, the mean of the values in each of these features, their standard deviation, the minimum value in these features. Here, 25 percentile means the first quartile. So the first quartile, the second quartile, and the third quartile, and then also displays the maximum value in each of these features. So this was a list of the basic commands that are used to read a data set and basically understand the data before you delve into pre-processing and other things.
Surround